Alright, I guess we'll go ahead and get started. It's pretty close to 10, so let's roll with it. So, everyone, have a good morning so far? Yeah, sir. You awake? Sure. Alright, I know that feeling. I just got down here like 15 minutes ago, so it's alright. I'll speak from the Cincinnati area. So I'm not awake yet either. It's alright though. So, this is as I like to call STRC. I don't know why it sounded cool, and I just kind of made an acronym out of it. So it's the Security Training and Research Cloud, and this is hi. Hope everyone's doing all right. Yeah. I know I'm happy to be here. I hope you all do. So here's a little bit about me. I just graduated from U of L with my master's. I also got the graduate certificate for Network Information Security, and U of L is also where I did my undergrad. So I've got a couple certifications, CCNA, GNCIA, which is Juniper, Security Plus, Net Plus. I'm a Microsoft Office Certified Master Instructor for 2003, if anyone even remembers that. It's like so far, that was high school, I don't even remember that anymore. So I really love Linux. A lot of people that I went to school with, we all really like Linux, and that's kind of where we had a lot of fun. And I really like networking. That's kind of been something that's been of huge interest to me. I actually ended up working for U of L for the CCS department as their network administrator for a couple of years. That was a great opportunity, so I want to thank Ron for sitting here for that great opportunity, as well as the department as a whole. I would coincide with the hacker term. I really like to tinker with things. I try to break them and then fix them, because that's kind of the whole point. A lot of people, I'm sure, are here to learn a little bit more about security and how can we make it better, because it's been an ongoing problem. And that's kind of where I wanted to go with this whole cloud initiative, is we need a place that's safe for people, that they can train, they can learn about this. So we just had DerbyCon this past weekend. That was an awesome conference. If you've never been there, take the time to go next year. It's awesome. Even if you can only go for a day, all the videos get posted online, and it's just a great place to go. Everyone there is a big family, and it's cool. So, does anybody else kind of coin themselves a hacker as well? Anybody else? Yeah, I got a few. That's good. I think that's great. And I don't necessarily look at it as, oh, I'm a malicious hacker, I'm going to break into your stuff and steal everything. Like, the idea that I have of hacker is I like to hack away at things until I figure out how they work. And thus, I came from an engineering school, so like the story of an engineer, let's do it just because we can, not because we should. And that's how I think a lot of innovation comes out of that, though. And I'm really hoping that innovation comes out of this type of effort, and I hope it's something that other people can put up and deploy and kind of spread the love, so to speak. And of course, security is also paramount. So, enough about me. STRC is a cloud. How many people hate the word cloud? I think everyone should raise their hand. So cloud tells you absolutely nothing, right? It's the cloud. Okay, well, what does that mean? We'll get to that just a little later. So it's a learning environment, and it's really safe, because virtualization has been a great thing to everyone in the industry, whether it's actually security, just information technology in general. And we used to have to say, well, let's deploy a whole system. Well, now the system broke. Well, now we have to redeploy the entire system. And so virtualization is a lot better. We can say, oh, well, it broke, we just revert to a snapshot and it's fixed again. So that's pretty nice. We go back and investigate what went wrong and hopefully fix it for future occurrences, but VMs are a great environment to work in because it's okay to break it. It's easy to fix. It's fast. I need to duplicate a Windows XP VM 100 times. Bam, 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 bam. Done. Alright, so I'm not going and trying to deploy fog and multicast image an entire lab, or going to each individual computer and installing all the software that we need. VMs make things a lot easier. This particular build out was really cheap. We didn't actually spend $3,700. That's the cost of what all the equipment was together. And we'll go over the equipment a little bit later. But really $3,700 isn't a lot. It's kind of a lot for some government entities, especially with the government being shut down right now, right? So no one's got got money, but I think in the grand scheme of things, that's pennies to a lot of industries. So it's great to have something that's cheap and flexible that you can just put wherever you need it to be. Almost entirely virtual. So I get that's kind of weird to think, well, it's virtualization. Of course, it's virtual. I mean, like almost everything is virtual, besides a few key components in the physical infrastructure. We'll talk about that a little bit more later. And so this one in particular is focused on security. We're not about, hey, we need to deploy an entire cloud so that everyone can host all their stuff in the cloud, and we can put all of our files in the cloud. No, we want the cloud to be there so that we can break it. And then when we break it, we want to fix it. And then when we fix it, we want to stop it from breaking again. So it's that whole life cycle thing where we deploy, we break, we fix, then we try to break it again and make sure that our fixes were in place and nothing bad happens. So just so you're aware, this build out is really more of a proof of concept. It's not like, hey, let's go deploy it in every enterprise or in every school or wherever someone needs it. This is just kind of a slow start to something that could be a lot bigger in the future. So the cyber defense team, which if you haven't heard of cyber defense, great program. It's a group of 8 individuals that are college students, 2 could be grad students. And they basically go and defend an enterprise network. So cyber defense, we need to train, right? We can't just go in and, well, we don't really know what we're doing, but we'll hack away at it and see if we can get it. No, we need to be able to train and prepare for competition, and more importantly, for the real world. So cyber defense is great because you can make all your mistakes in this training environment, and then when you go out in the real world, you don't make those mistakes again. So for people who are employers out here, if you see someone who says, yeah, I competed in cyber defense, they get a lot of good training value out of that. They are a step ahead of all of their peers, hands down. Even if they're just starting out their first year, they get so much experience in those 2 to 3 days of competition, it's unreal. So our traditional way of preparing was, all right, we had this lab. We've got about 15 systems in the lab. I'm going to go in about 2 hours early. I'm going to start reformatting all these systems and tweaking a couple things, reconfiguring things, and then everyone's going to come into the meeting for about an hour and a half. We're going to do a little lab environment, have some hands-on activity, and then we're done for that day. And then next week, we do the same thing. I come in 2 hours early, I reformat all these machines, and it becomes a very tedious process, especially for all the students, because with cyber defense, it's mostly student-run. We don't need a lot of help from professors and staff, because we're motivated enough to go out there and get the stuff done. But at the same time, there's this huge tedious process. So one of the other requirements that we had was we want an actual red team to be able to remote into the network and attack our systems, just like we would do with cyber defense. So we want to replicate the cyber defense environment as best as possible. And with that, you're also representing actual enterprise as best as possible. We actually deploy DNS, we deploy email, you've got VPNs, you've got all of your web services, e-commerce, databases. Everything you can imagine in an enterprise, we can replicate in this environment. So not only are we getting ready for competition to try and win, but we're getting everyone ready to go out into the real world, face real world challenges, and be able to solve them effectively without having someone breach their systems. And of course, the networks need to be dynamic. Extremely dynamic. We've got networks that come up and down all the time. We've got red teamers that move between networks to act as though they're coming from different areas of the internet. So we have like our own internet infrastructure built into this. And to be quite honest, I really needed something for a master's project. It seemed like a really cool project. I mean, what more could you ask for of, hey, I'm already involved in this, I want to help make it better, and I'm going to get some credit for school out of it. So I thought that was really great. So what is it really? Well, infrastructure as a service cloud is probably the best thing that I could use to describe it. It's a little bit more defined than just cloud in general. And again, I really hate cloud. I think it's kind of weird. Someone actually suggested while I was building this, I need to go get some cotton balls and like glue it to the rack and make it look like a real cloud. I thought that was pretty neat. So we've got 5 Dell 1950s. Those are pretty old servers, but they work great. They've got 16 gigs of RAM each. You can buy them used on eBay for 150 bucks or so. I mean, they're plentiful. Enterprises have gotten rid of these things for years, so they're just sitting out there on the used market. So they're very cost effective and they work. You don't need something that's brand new. You don't need to go buy Cisco UCS chassis and a bunch of blades and unified fabric, all this other craziness. You can just use this simple equipment to at least get a lab environment going. If you want to scale it, yeah, you probably want to have some better stuff later on. And then we have a 2950 that's our NAS. We're using ZFS across 6 hard drives, so 160 gigs times 6, that's not a lot. That's not even a terabyte. But we don't need that. Alright? This was all about keeping it small, keeping it what we need, but still being flexible enough to do what we need it to do, and maybe a little bit more in the future. Then we have a single Catalyst 2950 switch for the network, and I do mean a single switch for the entire network. No routers that are physical in the entire network. So, for those of you who don't know, this is a really old switch. It has like 24 10100 ports and 2 gig ports, and that is it. So it's not the newest piece of equipment, but we didn't have to pay for it because we already had it. We made it work, and that was awesome. So, working in education anyways, the thing that I found is that for a lot of the stuff that we want to do, we were like, yeah, that's great, let's do it. But you have a budget of $0. So just make it happen if you really wanted to. And so that's where we're getting stuff like this. You can reuse old equipment for lab environments. It's probably one of the best things that you can do. And then I actually invested in some nice UPSs. That was really kind of important because if everything went down, then what's the point of having the cloud? So that was really important. So I want to go a little bit further into this. So the one switch thing, it was really important to me. I didn't want any other physical networking hardware in the build out. Not initially. I wanted to make sure that this could be built without relying on routers and firewalls and all this other stuff. I wanted it to all be virtual. Now we can implement stuff physically into the networks. We can have them chained down as far as we want to. But in the actual build out, nothing besides that one switch is a physical piece of networking equipment. You can also use like host-only adapters if you need to. If you want to have contained networks within a single server, you can do additional switching with something like the Nexus 1000V, which isn't out for the center yet, but if you're using VMware, that's a great thing. It's something that I'd like to have used, but it's just not there yet. But that would have made the VLAN management and the distributed network across the cluster a lot easier. At least I thought it would have. So hopefully in the future that's something we can move to, and we can kind of look at not having to manage that old switch. So PICs didn't happen. So I actually built it. This is what it actually looks like. It's sitting in the data center at the CCS department right now. It's running. So you can see there's a little PICS 501 up top. That's actually not part of the build out. It's just there because we used it in an experiment once. And we'll talk about that a little bit more. But you got the 5 1950s and 2950, and then those are our 2 UPSs. So the nice thing that we have at the data center is we actually called physical plant over and they installed some more outlets for us because we were running out. So each UPS is plugged into its own 20 amp circuit. And each server has 2 power adapters, each going to each UPS. So I can shut an entire UPS down, or an entire breaker can blow, and the cloud still is up and running. And that's awesome. And then everything in the data center goes to the diesel generator. So if the power at the CCS department were to go down, we've got diesel generators backup. And those are things that you do in the industry for data center operations. You want to have that redundancy in there. So we're trying to replicate that here as well. Looking at the back, you can see that's all the cabling I needed. So I really didn't need, and actually I guess that's 48 ports. So I didn't need all but a couple cables. So there's 2 cables going into each server. One's for management and the SAN access, and the other one's for actual VM access and public internet access. On the far right here, this blue cable, that hooks into the CCS's network, and that's actually where we get our internet connection from, and it's just on a different VLAN than everyone else. The two on the very far right are the gigabit ones. Those go into the NAS. So we have at least some speed with the NAS going to each of the different virtual hosts. And then that other cable that just looks terrible. Sorry, I don't like bad cabling, and it just kind of happened. But that actually goes to another version of this cloud that the InfoSec class built out for just their class, and that's all on them. And we'll talk about that. So this is a physical networking layout of that switch, and it's really just that simple to set up. There's not a whole lot of work of, oh, okay, I need to make sure I get these cables in the right order. No, everything's managed through VLANs, and that's really all there is to it. So does anybody have questions about the physical infrastructure so far? Oh, all right. So the software that we use. We did a lot of research on what do we want to use. We had a VMware license at the time. There was also KVM that we could have used. And then we started looking at Zen Center, and we found Zen Cloud Platform. We're like, well, that's really cool. We can actually cluster servers like we do with VMware, but we don't have to pay for the license. Oh, and I can cluster more than 3 at a time. Awesome. So we decided to go with Zen Cloud Platform. And then if you don't know a lot about Zen Center 6.2 is the newest release, and that's been released as an open source product. You don't need to pay for that. So if you're doing small cloud build-outs, you can use Zen Center, and it works very well, actually. I'll show you that a little bit later. So the storage appliance that we're running is, we installed FreeNAS on it, which is also an open source product. You can use that for free. It's worked really well. It's easy to manage. There's not a whole lot to it. And all I did really was set up the ZFS, which basically emulates like a RAID 5 across those 6 disks. And then we set up a few NFS shares, and that was all we had to do with the file server. And so the network is kind of the interesting thing. We're running Viata core routers. So Viata, I found out about, I guess, 2 or 3 years ago now, when I was at a friend's conference down in Florida, and it's a software-based router solution. So it's I think it's Debian-based in its backend, but it's got a nice little CLI. So if you're familiar with Juniper, especially command line, you'll be very comfortable in Viata. Cisco, you've got a little bit of a learning curve to do, but it's not real bad. I mean, I started out in Cisco, and then I picked Viata up pretty quick. So they've got 2 different versions. They've got this core version, which has all the open source components, and then they have a paid subscription version. You get extra things like gateway filtering. They just added dynamic multipoint VPN. They added multicasting recently. So you pay for what you get, I guess, and since I didn't pay for anything, I just got a router out of it. But it works well. I mean, I can still do OSPF. I can still do BGP. I can still do RIP. I can still do IPv6. Its IPv6 is great. We've hooked it up to a Hurricane electric tunnel, and we've tunneled IPv6 internet into our cloud and never had a problem with it. It also does VPN tunnels if you want to do site-to-site IPsec, L2TP tunnels, and you can actually manage the users in there, or you can tell it to authenticate against a Radius or CACAC server. It does OpenVPN very nicely. So you can set up an OpenVPN server just from the command line real quick, done. You can set up OpenVPN site-to-site tunnels. And that's all in the free version. Like, you don't have to pay to get all those features. And that's some of the stuff that we use a lot. And having something that's free, it's like, okay, deploy, I'm done. That was awesome. So we use a lot of the auto routers in this. And we started to do that in the CCS network, playing with having it in a production environment as well. And it ended up working out very well, unless like your SAN dies and now the VM can't like write the disk anymore. So things that have already got the DHCP address are okay. They can still route. It's all in memory, but things that try to get a new one doesn't bode too well for them. So that's the type of software just in the infrastructure that we use. And with Viata, I mean, we have our own internal version of the internet basically. We're running BGP across the entire core of the network. So individual nodes can then peer in, and then they can have their own network down there, and they can talk to each other just like they talk across the internet. And this is one of the few places I've heard of someone doing that. I'm sure there are others out there that I just haven't heard about, but I thought that was pretty cool that we're pretty much saying we're going to replicate the internet in this small little environment and launch attacks if they're getting launched across the internet. So that also brings into play new attack vectors, like let's attack BGP because we can. So you don't want to do that out on the internet, obviously. That's bad. People get upset. People start calling Knox, and Knox start hunting you down, and your ports get shut down. So that's something new. A lot of people don't talk about that. So like with cyber defense, we don't get exposed to that because we don't have to deal with that in our enterprise networks. But when we're doing some training, we can bring those type of attack vectors into the training and say, hey, you can attack BGP and actually, so we have like Google, let's say, or any other search engine or email server. So you can actually inject the BGP routes and have all of the information coming straight to you. And the end user isn't going to know. It all looks pretty legit. But the people on the network side that are investigating network intrusions and network problems, they'll see, oh, the BGP routes changed. We should probably fix our BGP peering so that doesn't happen. Or we need to test it. We're actually calling up the ISP or the NOC and saying, hey, there's a problem with BGP. We need to get it investigated and get it fixed because traffic's going awry. And that's a real world scenario that happened with Google. That legitimately happened. I don't know if anybody remembers that, but there's a bunch of Google traffic that ended up in like Africa. And it was because BGP routes got moved around and it all went to the wrong place. So some of the stuff that we've used before, I know it's a long Cisco list, but 5505 ASAs, PIXs, 1841s and 2600s. These are pretty low-level things. These are not like, hey, I'm going to be an ISP and route with this kind of stuff. But it's great for our type of environment. Again, the switch is only 10100. We can only go so fast. So a lot of this stuff you can get out on the used market, and that's why we have a lot of it. Or the department has a lot of extra Cisco equipment laying around that we weren't currently using, so we can use some of that kind of stuff. But this gives people more experience. Instead of saying, all right, we'll just jump on like GNS3 or some other routing virtualization thing and play around with it. Well, let's do it in like the real cloud. So we'll throw an 1841 in there, and we'll hook it into like the internet's core and then into their little network core. And they've got some VMs behind it, and they can set up their own firewalls and ACLs. And when someone starts attacking, they can actually see it on the ASA or the 1841. They can see those attacks coming, and then they can block it right there at the router or the firewall level. So that gives them good practice of saying, hey, I'm on this Linux server, and my network guy's sitting next to me. Oh, I see an intrusion. I turn to him and say, hey, block this IP address for me. He blocks it on his end. I stop seeing the attack, make sure nothing actually bad happened, and then we're good. And then we can do our reporting procedures after that. So this helps really solidify the team environment with us, especially getting that practice of, I can't do everything by myself on this one server. I need to let other people know that things are happening in this network. So a lot of times with the cyber defense teams, you've got different subject matter experts. So you got your Windows guy, your Linux guy, your network guy. We usually have a guy that's really just dedicated to business side tasks. We have business injections that we have to complete. We have to have memos written up. And if anybody's worked with engineers, you know we're bad at like telling you what we did. We're like, yeah, we did it. All right, next. So it's nice. It really is. It's great to have guys from the business who come out that have had more time doing those business type tasks to help us along. And we can relay that information, and they've got the technical side and the business side that they can then convert it over and give a good report that's easy for everyone to understand, not just a technical person. So one of the other things that we didn't do was automate anything. So how many people have actually set up their own cloud or an enterprise cloud before? Anybody? A couple? Yeah. So how hard was that? Like, did you use cloud automation like CloudStack or what? Puppet. Puppet? Okay, so that's probably a little bit better solution because there's a lot more documentation to that, right? It's been around a little bit longer. So one of the things we decided not to do is to use this automation software. And it really became clear a couple months later, after we started working on this, when the CCS department wanted to build their own like enterprise grade cloud. And we started looking at like CloudStack, OpenStack, and it just became a huge headache. And we realized that we were glad that we didn't even attempt to do that with this deployment, because those types of automation softwares are really designed at the enterprise or at a service provider level. Hey, I need a VM, click, I got one. Cool. I need an entire network. Where do I click to get an entire network deployed? You don't. No one's done that yet. So we just manage everything through ZenCenter, which is their console. It's similar to like VMware's vSphere, if you've ever used that. And I mean, sometimes simple really is better. The KISS method has got me a long way. It's not always the most elegant solution, and obviously this could be a little bit better, but it definitely does what we need it to do. And there's no ifs, ands, or buts about it. It does exactly what we want it to do. And that was really important. So, I know we keep going back to cyber defense, but that was kind of like our core user for this whole cloud, but that's what this gets used for mainly, is cyber defense training and practice. I mean, any of the guys from cyber defense can shoot me an email and say, hey, can you set up a network with this type of stuff on it and give me access to it? Sure, here you go. You know, give me a couple hours to get everything configured and you're good. Now, yeah, a couple hours might be a long time, but we don't have a whole lot of people coming in and asking, because if we did, then it'd be like, well, give me a couple days to do that. And so, sure, if we did some automation type stuff, yeah, I'd be like, click, 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 done. Here's your little network. But I don't think it would be quite as effective, because I actually go in and I change configurations on Windows systems or on Linux systems, and I make them inherently insecure just to mess with them. And that's kind of the thing, though, is that if they don't know about all these things that make Windows or Linux or OS X or BSD or whatever you might be using insecure, then you're not really helping the fight as much as you could. So that's something that we really try to harp on, is learn group policy. Group policy is very powerful. It's also very scary. There's a lot of stuff that you can do with group policy that people don't realize, and a lot of it is kind of hard to find. If you've never messed with group policy that much, it's crazy. I mean, and simple stuff, like I'm going to make it so you can't change your desktop background. And that's on group policy. So they're sitting on their Windows XP client, and they're like, well, my background is like rainbow ponies, and I don't know what to do. And they're trying to like right click, and it doesn't do anything. Well, it's just group policy. All I need to do is tell whoever's working on the server, hey, check group policy, just make sure it's not a policy that's enforced throughout the whole domain. Or if they notice it on multiple computers, that would lead them to believe it's probably group policy, not a local problem. One of the other things is the network and information security classes at U of L. So the network security class and the InfoSec class cover a lot of the same topics, but the network security is more focused on the network side, obviously, and then InfoSec is like a broad spectrum of things that you could ever want to know about security. And because of that, the InfoSec class ended up building, or basically replicating, my build-out for their own needs. And at the end of every year, or every semester that the InfoSec class is offered, we always have a cyber defense style competition with the class. So we'll take and divide the class up in like teams of 5, and we'll give them their own different versions of the enterprise networks, and then we'll have a lot of guys from cyber defense and some other people actually red team against them, and try to give them a taste of that experience for a few hours. And that's kind of like their final exam, is, hey, you've learned all this stuff throughout the class, let's put it to the test in this environment. Right then and there, and it's done. One of the other things that they did is they, at the beginning of the class, everyone wants to break stuff, right? They take these InfoSec class, and they want to just like break into stuff right away, and we want to do all the cool stuff. So we said, all right, we'll go ahead and get it out of your system, and we deployed probably close to 80 VMs. And we said, here's a huge network. You scan it, and you tell us what's on it. And we had hidden networks throughout this too, where we put up like a Viata router, and we do tricky stuff where we, like, it's not really that tricky, but we do a one-to-one NAT to a single system, but there'd be like 5 systems behind that router. So if they got onto that system, if they weren't checking what the local IP was and they just assumed they just popped another box, they didn't even realize there's a network behind that router and adjacent to that other system that they happen to pop. So we started talking about stuff like that. And they got to learn this process of how attacks occurred and how can we scan and check for vulnerabilities. Another thing that they started to do too was implement web security. So how can we scan for web security vulnerabilities? So they had Jeremy Drew, who's going to talk later. He came in and he gave a presentation, and we can actually take the product that he works on. I'm gonna totally realize this. Is it Utiliday? Is that how you say it?
Mm-hmm.
Okay. See, I never say it right. So we can deploy that in the cloud too, and then they don't have to host it on their own systems. If anyone's been a college student before, you know that buying a laptop is a big deal and costs a lot of money. So sometimes you skimp on a few things. You may not have enough RAM to really run a bunch of VMs all at the same time. So you don't want to run like 2 VMs and your system. So we just put it in the cloud. You don't have to run any VMs. We can give you 2 VMs in the cloud, one to attack and one to have utility down there and figure out what's going on with all the web security stuff. So we started a few e-learning initiatives as well, and that kind of spawned out of the InfoSec class. One of the things that we kind of felt was that Blackboard really didn't provide some of the stuff that we were looking for as far as pushing content out. And there might be a way to do it. We just didn't know about it. So we switched to Moodle. U of L still uses Blackboard. They still use that for grades and all that stuff. But we built a Moodle infrastructure out, and we used that to actually give a lot more content to the InfoSec class. And we'll use it again for network security and future classes as well. So we started developing these lab environments, and then we would tailor-make videos and post them to Moodle so that the students could watch. And it basically guided them through how to effectively complete the lab. And it didn't say, okay, well, click this, do that, and you get the lab, you get an A. We said, well, here's a way to do it. That might be similar to how you want to do it, but this is the space you have to work in, and this is the sliver of answer that we gave you. So you've got all this other room that you can work out how to get into whatever. Another thing that we started playing around with was darknets. Those are fun. So that's basically like my own version of the internet within the internet. So this is like Subdog, I heard you like internets, right? So the cloud has its own, we've got the real internet, and then we've got like sub-internets inside of it. And so this kind of came out of our networking class, and we got really bored one day. We said, let's just build our own thing. Why not? So a bunch of us, like at our apartments or houses or whatever, we actually have VPN connections into this cloud infrastructure, and everything across the internet, which is just for transport, is all encrypted. But then we can talk to each other. We can. It's great for playing games. If you ever had to play a game and like deal with like setting up your firewall on your little router, and it's a headache every time, right? So why even bring a firewall into it? Just VPN all into a central place. Everyone can talk, no problems. So that was a great benefit. You can play a lot more games. But then we also started learning how the internet actually runs. So a lot of us run our own DNS servers. We all peer with BGP. I've set up a few mail servers here and there. Other people have set up like Git repositories that we can work on code, because we all went to school together. So we had central repositories that were private, because GitHub doesn't always, I think you have to pay for the private repositories. So we had private places that we can store our classmates that we were working on, code projects, whatever, and we didn't have to worry about anybody else messing with it. And then, of course, we have individual research projects. So if someone from anywhere really came up to me, I said, hey, I really want to explore X, Y, and Z. I'd say, all right, let's set something up for you. I'll give you access to it, and then you can explore whatever it is you want to explore. The department, now that they've started on their cloud, I think they're going to start pulling a little bit more onto their side. But for some of the stuff that is really, really specific, that maybe the cloud doesn't provide for them, they can come back to me and they can say, hey, I really need this, exactly this, and we'll make it work. Especially if it involves hardware components. So if they want to integrate hardware into their networks, we can do that in this cloud environment. So I try to do something good, and of course, no good ego sometimes. So problems that we have are, of course, the backbone of the network. It's kind of slow. We'd love to be a lot faster. I would love to have like an infinite budget and like go 40 gig fiber everywhere, and we just can't do that. It'd be cool though, it really would. And there isn't really enough RAM to do a whole lot. I mean, you can do some pretty cool stuff. We've had some pretty big network build-outs, and it works, but there's still a limit. You've only got so much RAM that you can work with. So what we end up doing a lot of times is, well, like no offense to Windows, but we need to slow down on the Windows VMs and have more Linux VMs. Because Linux will run with like 256 of RAM, no problem, rock solid. But I mean, we work with that, and that's fine. And a lot of people that don't have experience with Linux, they like getting Linux VMs because it's something new. It challenges them. It's all about learning. All right. So when they have their meetings and they say, "Well, I don't really know what I'm doing," that's fine. There's a lot of us there that know what we're doing. And then at the same time, I'll sit down on a Windows VM. I'll be like, "What do I click. I don't type. Like, I don't get this. I'm supposed to be typing, not clicking on things, right?" So I'm a big command line junkie. And then of course we could use some more CPU power. That just leads to things running a little bit smoother. Even like with the InfoSec class, they had a little bit newer hardware, but we had, like I said, about 80 VMs running, and none of them really got lagged out at all. Nobody had any problems with it. So that's what happens. They VPN into the network, and then they could scan and attack, and no one says they had any issues. Even if they were doing like VNC connections, it worked pretty smoothly. So the CPU power isn't quite as important as maybe the RAM, but it never hurts to have even more. So one of the other things too that I wanted to play with is CUDA. We have a parallel programming class that they do a lot of CUDA stuff, but XenServer has support for a GPU pass-through. So I can actually assign like a GPU to a VM. Pretty cool. So why don't we implement some of that stuff? And the effect that gives you is, all right, we want to teach you a little bit more about how these attacks occur. So you get into a system, cool. You dump hashes, awesome. Now crack the hash. All right, well, my little system here doesn't crack it fast enough. That's all right. We've got a CUDA system that you can use. Cracks a little bit faster. And it doesn't necessarily mean that they get better training value out of it, but it kind of speeds up labs. And in an academic environment, you've only got a semester to work in, so having a little bit of extra speed doesn't hurt. And then how do we like clone an entire network? That's something that I really want to be able to do. That makes a lot of people's lives a lot easier, and I think it has good benefits to the whole of virtualization, not just our particular needs. And is what I mean by clone an entire network is I built out this infrastructure. We've got mail servers and DNS servers and web servers and routers, and we've got like 6 different networks like in this global network that we have set up. Well, I want to take that and copy paste it into another area, and that way we can have 2 of the exact same networks and maybe just tweak a couple of things like the IPs. And that's great for cyber defense needs. So I don't have to sit there and build out 6 different competition networks. I build one and paste it 5 more times, and now we can have 6 teams competing with the exact same setup, no problems. So hopefully that's something I will get done sometime in the future. Some of the short-term things that I really want to get working on is a mixed vendor networking lab. So we've got a lot of Cisco equipment, and I think Cisco is awesome, but Cisco isn't the only person out there. And it's not necessarily the only person that you're going to see when you go out to a real job. So you got Juniper, you got Checkpoint, you got, I guess, Dell and Sonic now, Netgear. I mean, there's all these different companies out there that do networking, and I think that all of our students should have the opportunity to at least experiment or get accustomed to these different products. it just makes them better when they're going out in the job market. They can say, well, I'm not an expert at Checkpoint, but I've used it before. I understand a little bit about how it works. And so I'm a step above someone who's never touched it before because I've at least seen it and I can work around in it. And then I can become that subject matter expert in there if I need to be. And of course, with that networking lab, we want that to be accessible remotely. And we want to be able to tie all of these networking things in with VMs. So if they want to test their firewalls out on different systems, we can kind of like Lego style, pull this router out, put this one in, see if it works the same, if they understand how everything works the same. So let's say I'm really good at Cisco ACLs. I write my Cisco ACL, I test it, it works great. I can write some tests to automate that. And then I can say, all right, I'm going to pull that one out and I'm going to put in a Juniper router. I'm going to try to replicate the firewall rules in the Juniper router that I had in the Cisco router. I run my little script that does my test and see if the results come back the same. And if they do, then I probably have a good understanding of this other infrastructure that I know that I have in the previous. And then, of course, implementing physical servers. Sometimes you just need to have a physical server. And that is probably going to be a better tie-in to CUDA at the initial start than it would be to do like GPU pass-through. And then we want to look at extending the infrastructure across multiple locations. So if one place went down, that's fine, like the whole cloud isn't down. And that's just something that takes time and money, obviously, and hopefully people willing to help participate in this. And then I think another cool thing would be really testing, validating incident response. That's something we don't get a lot of time doing with cyber defense because we're always like, oh my gosh, how do I like fix all this stuff that's broken on here? I've got too many things to do, not enough time to do it. So I think doing something that's maybe a little bit longer and really gets people honed in on incident response. Because if you don't report things, nobody else knows what's going on and nobody else can help you fix the problem. So you might notice it, but you might not be the one that needs to fix it. Someone else down the chain might need to fix it. Or I'm just the network guy and I saw on the IDS that someone's attacking the e-commerce server. So I'm going to go to like the web security team and say, hey, someone's attacking the e-commerce server. Here's what I have. Can you figure out if there's any hole, legitimately patch it, or if they've already gotten in, how bad is it? And of course, I can block it on my end, but someone else still needs to go through and validate that either nothing happened or what's the damage that actually occurred. So, anybody have questions so far? Great. All right. No questions at all. All right. I want to try this real quick. I still have a little bit of time. All right, so this is a Kali game that I have running on this local system, and then let me find there it is. And then this is an XPVM that's actually running in the cloud. So I'm sitting here, just hooked into my phone. I'm VPN into the cloud, and I'm talking to this XP server over here. So I can run Metasploit if I want, or Armitage, or any tool that you want. This is actually brand new VM, so that's the wrong password. This is the problem with live ones, right? Alright. So I just ran a quick image scan, and I'm actually seeing all the ports that are open on this XPVM. Pass me, you can't tell from that. That's how secure I am. Alright, well, that's just not going to work, is it? How many people use Linux? Alright, so just while this is running, this is i3. It's really awesome. It's a tiling window manager. If you've never used it, you should play with it because you can do fun stuff like that. Like, you make that full screen, right? I can move that up on top of there, over there, over there. Or I can do stuff like that. It's pretty neat. It uses up all your window space. Alright. We'll see. Go through your 2.6 specs. .3G is not the best thing to be from. And so this is actually a detached console from Zen Center. So I'm using Zen Center to manage the XPVM in the cloud, at least right now. Hot. So how about that? That is weird.
You've got no key?
Yeah. Apparently when I push the key, it's doing something else.
Copy and paste from somewhere else on the screen.
Yeah, probably.
Just type password.
Yeah. Well, I guess that's not going to work. That is a problem with live demos. Sometimes it does not work. Do what?
The tap plate?
Well. So I didn't add a payload, but that's fine because that's kind of not what I was really looking at. But you can see it's actually making the connection with the exploit. If I had a payload attached, it would run just fine, and it would actually call back all the way across this little 3G connection and hit this Kali box. And that's the kind of stuff that we can do with our infrastructure. And that's the kind of stuff that the students really like to see because they don't have to sit in a classroom and do it. They can go at home. They can stay up till 3 o'clock in the morning if they want to. We don't tell them that they have to. But they can actually play with it anytime that they want, break it, and do whatever they need to do for their studies or to finish a lab, whatever the case might be. So, anybody have any other questions? Any questions at all? Alright, well, I really appreciate the time. I hope you all enjoy the rest of the conference. If anybody has any questions that they want to ask me in person, I'll be up here for a little bit, and hope you all have a good rest of the day.
There's no spring. There's no closure on it.
Blacks are fine. The problem is you don't know some of the stuff that maybe you
When did she
that was like
Actually, that's across.
probably a bigger problem than it was us. But that was just kind of one of those things. We needed something. Or like, we still use Blackboard as yeah.
I've been in
Yeah.
kind of start heading that way.
Well, I mean, I'm not there anymore. I guess
Because I know we're trying to get
I don't know what they require, but as far as like
One of them.
Andy did spot.
I 2 days back.
Almost.
And it's very $13 a month. You can get this for $10 a month. Yeah.
It's our new sergeant major. I don't have my address book yet, that's why I'm calling.
Yeah, one of the other guys he finds reasons.
Whenever they major everybody can
Yeah, he started
money because they didn't upgrade their infrastructure. So they don't have, they're way behind on the number of towers.
like 7 console pads open at a time.
Highly populated area, it'll see you get 2 bars. If you try to look at anything that's on data-wise, it will. You can call, but the data